this is Chycho. Welcome to Series 2 of the Language of Mathematics. Now, we're back at one of the first places where we did a little math on this wall, specifically, in Series 1, which was the real number set. Like I said before when we were doing that section, the real number set is super important because it keeps on coming up, and the way the numbers are broken up into different subsets is pretty important. So what we're going to do is recreate the real number set just in short form. I'm going to probably create it on that wall over there, and we're going to see how the way they broke up the numbers, the way the number sets are laid out, how they relate to exponents, which are basically radicals. Okay. So I got my music, I got my chalk, and I got a little bit of notes. So we're going to go ahead and draw it, and once it's done, we'll start talking about it, okay? Okay, zoomed in so it should look better. Now, real number set. If you remember from the first series, we talked about this and we broke down each subset. Natural numbers were basically 1, 2, 3, and we got it down here. 1, 2, 3, all the way up to infinity. Next level above it was the whole numbers, and the whole numbers was us defining the number 0. And since we defined it, we introduced it in a new subset and put a boundary between the natural numbers and the whole number set. So basically the whole numbers is just 0, 1, 2, 3, all the way up to infinity. And then we defined negative numbers, which brought us to the integers, one level higher, and integers includes whole numbers and natural numbers. So every set above includes everyone below it, okay? So integers was basically negative numbers as well, negative whole numbers. So it would have been, negative infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3, all the way up to infinity. And then after that, we define rational numbers. And rational numbers usually use, well, in my area anyway, we use the letter Q to define rational numbers, okay? So rational numbers would have been fractions, or anything that repeats or terminates. So it would have been just basically fractions. And then after that, we had the irrational numbers, which were basically any root of a prime number, or numbers like pi. So irrational numbers were numbers that didn't end and they didn't repeat. Now, how is this related to exponents? How the exponents deal with this number is, what the exponents do to the base number is basically broken down into the real number set, this whole thing here. So basically, break it down to these 4 subsections, and that way you'll remember how to apply any number put here to the base. Now, if you take the natural numbers, if you had your base number here, and you had a natural number in the small box. So, for example, if you had number 3 in the small box and number 5 in the big box in the base, so that would have been 5 to the power of 3. The way that works is, in the natural number set, what that does, clones it. So when you put a 3 in the small box and a 5 in the big box, what that does is it says multiply 5 together 3 times. So what happens is it goes 5 times 5 times 5. Okay? And that's the natural numbers. The next level up is the whole numbers, and all that did was introduce the number 0. And the way the number 0 works is, if you have anything in this box, it doesn't make a difference. It could be, WZ squared over Q, 100 in the front, all to the power of something else, blah, 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 square rooted. Doesn't make a difference what goes in that box. If you have anything in that box to the power of 0, it equals 1. Okay? So if you had a 5 in the big box and 0 in the little box, that would be equal 1. It doesn't make a difference what goes in the big box. For the integers, if you go one level above the rational numbers, or one level above the whole numbers, you get integers. Integers do negative numbers. Okay? So they introduce negative whole numbers. So when you have your natural numbers here, we went up to the whole numbers introduce 0, anything to the power of 0 is 1. Now, if you put a negative number in the little box up there, what it does to the big box, it flips it. So if you had 5 in the big box and negative 3 here, what the negative number would do, it would put it 1 over 5 to the power of 3. So you use up the negative to flip the number 5. Okay? And if the base number, if this number is in the bottom to a negative power, what it does, it kicks it up. If it's a fraction in the big box, what it does, it flips it. The bottom goes up top and the top goes to the bottom if you have a negative exponent. Okay? After the integers, we had rational numbers. Now, rational numbers are basically fractions. Any number that repeats or terminates is a fraction. Okay? So the way it works with fractions is, if you have 2 over 3, the denominator in the exponent becomes a radical, becomes the root. So if, okay, let's take a green. I'm going to do this thing right down here, okay? So if you have any number in the base and put it to a fraction, what happens is the top number in the fraction is the numerator, I think that's what they call it. That acts like the natural numbers, or the whole numbers. Well, you wouldn't put 0 in the fraction. That acts like natural numbers. So the top number, it just clones whatever is in the base, okay? The denominator in the exponent goes to the root. So for example, I'm going to do 5 to the power of 2 over 3. Let's do that.